Welcome to the subject Computer Fundamental. At present we are in chapter 7. The title of the chapter is Processor and Memory. We are studying the internal structure of the processor. Yesterday we considered some part of the internal processor, that is control unit. Today we will take up the next part. In today's discussion, we will study control unit, arithmetical logical unit, and instruction set and register. First is control unit. Point number 1. Control unit is the basic component of CPU along with arithmetic logic unit. Students who have studied CPU consists of two units. One is control unit, another is arithmetical logic unit. Point number 2. Control unit of CPU selects and interprets program instructions and then coordinates their execution. So it is the job of the control unit to select the instruction and interpret the meaning of that instruction and execute it. As seen in the diagram, control unit has some special purpose registers and decoder to perform these activities. Students, I have given you the diagram in the previous class. It is there in the PPT as well as in PDF file. So the same diagram is valid here. Point number 4. The special purpose registers named instruction register and program control register respectively hold the current instruction and next instruction for execution, and this way help the control unit in instruction selection. Students, you have seen the main central block diagram. On the left hand side you have got control unit, on the right hand side of the main block in the part itself you have got arithmetical logical unit. Point number 5. The decoder is a circuit to decode and interpret the meaning of every instruction supported by the CPU. So students, decoder is a circuit that will interpret as well as decode the meaning of every instruction. Point number 6. Each instruction is accompanied by microcode that gives very basic directions that tell the CPU how to execute the instruction. Students, so there is a microcode which will tell how to execute the instruction. Micro means small code. Next we will go to arithmetic logic unit. Point number 1. Arithmetic logic unit of CPU is the place where actual execution of instruction takes place during the data processing. Point number 2. When the control unit encounters an instruction that involves an arithmetic operations such as addition, subtraction, multiplication and division, and logic operations such as greater than, less than, it passes control to ALU. Students, when there are any operations, arithmetical logic operations, the control is going to ALU. Point number 3. Arithmetical logical unit has special purpose register and circuitry to carry out arithmetic and logic operations. So there is special circuitry which will help us to carry out arithmetical and logical operations. Instruction set. Point number 1. So instruction is nothing but set of instructions that can be executed by a particular processor. Point number 1. Every CPU has built-in ability to execute a set of machine instructions called its instruction set. So students, what is instruction set? Instruction set are the machine instructions which can be executed by CPU. Point number 2. Most CPU have 200 or more instructions such as add, subtract, compare, etc. in their instruction set. Point number 3. Each processor has unique instruction set. Hence, machine language program written for one processor will not run on other processor. Students, there is a unique instruction set for every processor, so it is not possible to run program which is written for particular processor on another processor. Registers, point number 1. Registers are special memory units that are part of CPU and not memory. So students, registers are related to CPU and not to memory. Point number 2. Registers hold information temporarily. Point number 3. Length of the register is equal to number of bits it can store. So students, register is where data is stored temporarily, and the length of the number of bits in a register is its length. The length of register is called word size. Most of the today's CPU have 32-bit or 64-bit registers. Point number 5. Bigger the size of register, the faster computer can process the data. So larger is the size of the register, data can be processed at single process. Registers and their functions. Point number 1. Although the number of registers varies from computer to computer, there are some registers common to all computers. Point number 2. Registers and their functions are as given below. 1. Memory address register (MAR) holds the address of the active memory location. Point number 2. Memory buffer register holds the information on its way to and from memory. 3rd. Program control holds address of next instruction to be executed. 4th. Accumulator accumulates results and data to be operated upon. Instruction holds an instruction while it is being executed. And 6th. Input output, it communicates with I/O devices. So students, the common registers which are available in every instruction are memory address register, memory buffer register, program control, accumulator, instruction, and input output. So their functions are identified. So today we have studied instruction set. In that that is CPU, we have studied control unit, we have studied ALU, we have studied instruction set, registers and their function. Please write this in your notebook. Thank you.